everyone. So this is Pooja Sharma and today I'm going to explain the topic type conversions in C programming. Prior to this, we have already discussed about the operators, type of operators and operator precedence and associativity. So after that, as per the AKGEC syllabus, we have another topic, next topic, the type conversion. So what is actually type conversion? See, whenever we want to convert any particular variable from one data type to another data type, then that means it is type conversion. So typecasting, we also call it as typecasting. And so typecasting and type conversion, it is actually, so typecasting and type conversion, it is actually a way to convert a variable from one data type to another data type. So if we have a, if we can say if we have a variable A and it is of integer data type, and we have another variable which is of long data type or float data type, so it is actually converting a data type, converting a variable from one data type to another data type. We'll see some examples. See, if you want to store a long value into a simple integer, then you can typecast long to integer. So this is how it is actually done. So basically there are two types of type conversion: implicit type conversion, which is actually internally by default it is done by the compiler, and explicit type conversion, it is this type of conversion is done by the user. So this is basically user defined type conversion, and the implicit type conversion, it is internally done by the compiler. So when we talk about implicit type conversion, I have already said that C compiler, it automatically converts any intermediate values to the proper type, so that the expression can be evaluated without losing any significance. This automatic conversion, it is known as implicit type conversion. So see, we can see C compiler, it converts any intermediate values to the proper type, so that the expression can be evaluated without losing any significance. If the operands are of different types, then the lower type is converted to the higher type before the operation proceeds. So if we see, we have two different operands. This is this A and this B. This A is of integer data type and this B is of float data type. So, or we can say if we add 10 plus 2.5, so our output would eventually be a float value, means the output would be 12.5. So entire solution would be converted to the higher data type. So this is what this line means. If the operands are of different types, then the lower type is converted to the higher type before the operation proceeds. So these two operands, see, we can see 10, we have one number 10 and another number as 12.5. So this 10 is actually of integer type. This 10 is actually of integer type, and this 12.5 is actually of double type, or you can say the float type. These are two different types of values. So these two operands are of different types. So, and the lower type, this would be converted to the higher type before the operation proceeds. So since we are adding a lower type with the higher type, so our output would eventually be the higher type. So it would be internally, it would be converted to float value. It would become 10.0 and the output would be 22.5. This is how type conversion is done, and we know the result is of higher type. So 22.5, it is of higher type, it is of float type. So basically this is the conversion hierarchy. So C programming, it uses rules that in all the expressions except the assignment operation, except the assignment, any implicit type conversions are made from lower to a higher size type as shown below. So in all the expressions except assignment, whenever we are doing any type conversion, it is actually done from lower to higher type conversion. So if we are evaluating integer and char, so the resultant value would be of integer type, because integer is of higher type conversion. Integer is of higher data type, is basically higher data type. So this is how, this is actually the conversion hierarchy. This hierarchy, it can be used while evaluating expressions. So whenever we are evaluating two expressions, we can say if we are evaluating, the expression includes one float value and the another is long double value. So this first of all, internally this float value will be converted into long double value, and the resultant would be the long double value only. So this is actually the hierarchy. First of all, we have short and char, which are of, as per Turbo C compiler, these are of 1 byte, integer, this is of 2 bytes, and similarly long double is of 8 bytes. So this is how, this is our actually the hierarchy. Let us take an example of implicit type conversion. As we have already discussed, what is implicit type conversion? C compiler, it uses some rules that all the conversions are made from lower size to a higher size as by the C compiler only. So in implicit example, in implicit type conversion, let us see, we have a variable x, int x. So x variable has, so we have a memory block. So the compiler would create a memory block naming it as x, and it has a value assigned as 10, and a variable, another character type of variable which is of y, and it has internally a value a. So this is of integer type. So this is of integer type, and this is of character type variable. So internally, if we are evaluating this expression, x is equals to x plus 5. See, we can say x is a integer type variable and y is actually a character type. So if we relate to this one is of lower data, this is actually a lower data type, and this is a higher as compared to the character. So whenever we are converting this, so this lower would be converted into int. So the value y has a character, and ASCII value of a is 97. If we check the ASCII table, so the character a has a value 97. So whenever we are evaluating this expression x equals to x plus 5, so currently the x variable has 10 value and the a variable, so basically the integer value or the integer value as per the ASCII table of a is 97. So now the resultant value of x would be 107. Clear? So we can easily say that the x would be the new value. So we can easily say the new value of x would be 107. Here we have written, first of all, the y implicitly converted into int ASCII as per the ASCII value of a, and the ASCII value of a is 97. And whenever we are evaluating another variable, let's just say float, so z is of float type, z is equals to x plus 1.0. This x is of integer type. It has already been mentioned here. X is of integer type, and this 1.0 is of float type. And the variable z, it is already defined as a float type value. So variable z is of float type. Now to convert this expression, to evaluate this expression, implicitly the compiler will convert the value of x to float, because the higher data type is float. So the value of x here, the value of x was 107. Last value, evaluated value of x is 107. So the compiler would make this value as 107.0. Now if we evaluate this, z is equals to 107.0 plus 1.0, and the resultant value would be 108.0. I hope this is clear to everyone. So so we can easily check. So all these values are implicitly converted via compiler. So we have not mentioned that we have to convert this y to integer. No, this is not done by the programmer or developer. This is implicitly done by the compiler, C compiler. In this example as well, this x is here. We have defined this x as integer type, and we are evaluating this x in an expression where the resultant value and the other variables are of float type. So this is the implicit conversion. The output are quite correct. Now let us move to the next slide. This is another example, and in this example is also of implicit type conversion. We have a variable I is of integer type. We have a variable I, and it has initially saved a value 17. So this is of integer type data. And we have another variable known as C, which is of character type data, and this has a character C. If we check our ASCII table, so you know what is ASCII table? ASCII table is actually all the characters of the keyboard, whatever the key we are pressing, so all the characters have some decimal values. So in total we have around 255, 0 to 255 characters. 0 to 255 characters. So entire character set has some 0 to 255 characters, and these total 256 characters has some decimal value. Suppose like 0 has a smiley, A has a value 65, so the decimal value of A is 65, small a has 97 value. So this is how everything is mentioned. So whatever key we are pressing, it has some decimal value. Then only that decimal value is converted into the binary value, and our machine, our C compiler, will actually work on it in this way. So this character C has, obviously, if A has a value 97, then C would have the value 99, character C. This is sequentially done. Now let us see. So this is the integer, I is of integer type and C is of character type. We have another variable named float, which is a float type, and the name of this variable is sum. So here the variable is float. See, all these three variables, these three variables are of different data type. Now we have to evaluate this sum. Sum is equals to I plus C. We have sum is equals to I plus C. I'm again repeating. If we check, sum is of float type. Sum is of float type. I is of integer type, and C is of character type. So float has 4 bytes. Integer has 2 bytes. Character has 1 byte. So what we are going to do is, when above code is compiled and executed, it produces the following result. So here what is actually doing, first of all, the character's value C is converted to integer because it has to work with integer type value. So first of all, this is converted to integer, and the value of C would become 99. Value of C would become 99. So I has 17 and C has 99 integer value, because C would be evaluated or C would be calculated with I value, and I is of integer type. So 17 plus 99, the resultant value would be 116. And this 116 is saved in sum, and sum is of float type. Sum is of float type. So when we talk about now, this entire expression would be of integer type, and when we are saving it to float type value, then our resultant would be of float type. Now let me just explain this once more. See, what we are here doing, we are, first of all, what we are actually here doing, we are adding an integer and a character type value and saving it into a float type value. So this is what we are doing. We are actually adding an integer type value to a character type value and saving it into a float type value. So first of all, when we are evaluating this expression, this character type, or we have this lower data type value, would be converted into integer type value. So C would have value 99. I has already value, that is 70, and when we evaluate this, it would become something like 116. And when we have to save it to a higher data type value, that is a float type value, so the entire value would become is a float type value. So the resultant value sum would be of float type value. So 116 would become a float type value, and the resultant answer is 116.00. So we can see when this code is compiled and executed, it produces the output, that is the value of sum is 116.0. In this entire program, it is very simple to understand that first of all, the value of C is converted to integer, but as we know, the final value is double. So as per the usual arithmetic conversion applies, compiler first of all converts the I and C into float and then add that yielding float value. I hope this is clear to everyone. Now let us move to our explicit type conversion. This type conversion is forcefully done by the programmer. So this type conversion is performed by the programmer, and they post some data type of the conversion of specific type, which is known as explicit type conversion. So general form, if we talk about general form, suppose we have a variable A is of integer type, and we have to convert it into float. So this is how the expression is done. First of all, the type name, in which type we want to convert this variable, and here is the variable name, or you can say here even an expression could also be included here. Suppose we are doing int, we are converting this entire expression A plus B into integer type, or we are converting this entire expression into float type. This is explicitly done by the programmer, not implicitly by the compiler. Here we can say the type name is actually a standard C data type, whatever the data type we are using, integer, float, char, double, long, double, whatever, and the expression could be either a constant, this value could either be a constant, this value could either be a variable, and it could also be an expression. So if we are doing float, if we are writing it in such a way, float 10, 10, then the resultant value of this would be 10.00. I just hope this is clear. Another example of this is, suppose if we have a variable, suppose if we have a, suppose here are some examples. Let us say we are doing int 10.5. So output would be 10. Only the integer value would be evaluated. This is done by, this is actually the explicit type conversion. This is the basic format of explicit type conversion. There are some uses. Let us take an example. We have done here. This is an example. This variable x is equals to int 7.5. So now first of all, this 7.5 value is converted to integer type, and this is known as truncation. See, this 7.5 is of higher data type value. This is of float type, and this value is truncated, and only the integer part would be saved. So x has a value 7.5 is converted to integer by truncation. So now x would have 7 only. Okay. Now let us move to another example. Int a is equals to int 21.3. So 21.3, this is a float type value, and it is converted into integer type value. So obviously the 0.3 value would be truncated, and 7.5 is and 21.3 is converted to 21. Is converted to 21. This would be 20. So this would become 21. Divide by integer of 4.5. So 4.5 is a floating type value, and it is converted. It is explicitly type conversion, and the type conversion is done in integer type. So the 4.5 would become 4 only. Now we have 21 by 4. It would become, the value would be something like 5 point something. But only because internally we are explicitly we are doing it as an integer type conversion. We are converting the floating values into integer type. So our answer would be 5. So and this entire expression would be evaluated as 21 by 4, and the resultant value would be 5. We have another example. B is equals to double sum by 9. So this entire division is actually done in floating point mode. So first of all, this value sum would be converted to double, and this entire expression is done in double mode, and the value would be saved in double form only. Here, first of all, the a plus b is evaluated, and it is converted to integer type. So the result of a plus b is converted to integer type. And when we have this expression, first of all, the a is converted to integer type, then it is added with b, and whatever would be the answer, it would be evaluated. The answer would be whatever variable is of higher data type. So a is first of all converted to integer, and then it is added to b value. Last example here is p is equal to cos double x. First of all, the x value of x is converted to double type of data, and then as per the expression is given, it would be it would be actually evaluated in such a way. So whatever be the value of x, first of all, it is converted to double. So we can say if x has one value, so the output would be cos 1. So whatever would be the value of this, it would be evaluated in such a way. This is an example of explicit type conversion. So we have a variable a is of float type 5.25, and what we are doing is int b. We have another variable b is of integer type, and we are explicitly converting the value of a into integer type. So we have a as float type. Explicitly we are converting this. This is the format. This is the syntax of explicit type conversion. So we are explicitly casting from floating to int. So here the value of b would only be 5, because first of all a has 5.25 value. This is a higher data type value, and it is explicitly converted into lower data type value, integer type. So this part would be truncated, and b would resultant have 5 value. So we can say the value of b here would be 5. Let us move to another example. this is char c is equals to a. Char c is equals to a. First of all, let me just erase this. Char c is equals to a. C. Okay. So we have a variable c. C has some value a. This is a character value, and the expression is int x. So x is of integer type. X is of integer type. And explicitly, we are converting the c variable into integer type. Explicitly, we are converting c variable into integer type. So first, so what would be the ASCII value of a? The ASCII value of a is 65. So first of all, this is a character type value. This is a character type value. It is converted to integer type value. So this would become somewhat like 65. So this variable has ASCII value 65, and so this a character has ASCII value 65. So the variable c would have stored 65 value, would become 65, means the integer value, and then the resultant x would have 65. So explicit casting, this is actually an explicit casting from character to integer. So we can say the value of x here would be the value ASCII value of a. This is another example of explicit type conversion. We have a variable a which is of short type, short data type. So initially the variable is of short, we have initialized a variable a as of short data type, and another variable, integer variable, which is b. So this is a short data type, this is an integer variable. What we are doing, explicit, this is actually implicit type conversion. B is equals to a. So now first of all, a is of short type and b is of integer type. So this a would become integer type. This is implicit type conversion. So if we print this printf a, output would be 10. The current value of a is 10 and b would have 10 only. So this is the assignment variable. I hope this is clear to everyone. Thank you so much.